Welcome all of you to this video of Maths Made Easy. Now in this video I am going to take up relations and functions. Now in videos before this I have taken set theory. Now here in this video I am going to take, as you can see, relations and functions. Okay, we are starting the chapter of relations and functions, and in today's class what I am going to do is I am going to take up ordered pair, Cartesian product, and then what are relations, what are functions. Okay, now in this I am sure this part of it is very confusing for you all sometimes. What is relations, what is functions? You read it once, then you forget it. Okay, so you every time you understand, you close the textbook, you forget it. So that is why I am taking this up, and see if you should be able to remember it very well once I have done this. Okay, so let us start with ordered pair first. What is an ordered pair? Now here we have what is an ordered pair? An ordered pair is just two numbers or two elements written like this. Even in art, when we have our coordinates, okay, we have our coordinates. So even in our coordinates, we have 2, 3, that is an ordered pair, or 3, 4, that is also an ordered pair. Okay, so these are all ordered pair. Now in an ordered pair, the order matters. Okay, so the order of the elements is very much important in ordered pairs. Now let us see what we are talking about. That is, if supposing we have this one given, 2a square plus 3b square is 35. Okay, and a and b belong to z. Okay, so A, B belong to Z, and this set should have all the elements of this set should be full ordered pairs. Okay, so they are saying express as a set of ordered pairs. Okay, express as a set of ordered pairs. Here same thing. Here the full set, you can see this, you can see the curly bracket here and here. Inside it should be xy, x1, y1, x2, y2, like that. So let's finish this first. X square plus y square, the given condition is x square plus y square is a 25. Okay. So every time we think, and x and y should only belong to whole numbers, very important. X and y should only belong to whole numbers, so we can't take negative numbers, we can't take fractional numbers. Okay, it should start from 0 and end in infinity. So here, first thing, if I take x as 0, then y is 5, right? Okay, so x is 0, y is equal to 5, because y square is 25. Then x is, if I take x as let's say 4, okay, if I take x is equal to 4, then y is how much? And we can't take y, though we'll get y square is equal to 25, y is equal to plus minus 5, but we can't take the minus 1 because y is a whole number, so we'll take only the plus 1. Now x is equal to 4, y is equal to how much? 25 minus 16, y is equal to 3. X is equal to 3, y is equal to 4. Okay, x is equal to, now x is equal to 5 if I take, y is a 0. Okay, now, so the set, what is the set now? The set becomes 0, 5. I cannot write 5, 0. If I write 5, 0, it is a different ordered pair. And here I am supposed to write all the x values first and then the y values. So 0, 5, and look at the bracket, comma. Okay, 4, 3 and a comma, 3, 4 and a comma, and 5, 0 and a comma. So these two are different ordered pairs, these two are different. As I said, the order matters. Okay, so the order should be correct. So this is one set of ordered pairs. Let's come to this. This is quite similar. Here, if I take a as 2. Now here a and b can be negative because it is integers. So if I take a as a 2, b is how much? B is, this is 2, 4, 8, 35 minus 8 is how much? 35 minus 8 is a 27. 27 divided by 3. Okay, so 27 divided by 3 we get a 9. So if A is 2, B can be a plus minus 3. Okay, we can take both the values here. If A is minus 2, then also B can be plus and minus 3, because minus becomes plus because of the square. If A is 4, let's take 4, then it is 16. 16 into 2, 32. 32, if I subtract from here, it gives a 3. This 3 divides it. B is equal to plus minus 1. Okay, if A is minus 4, even then B is equal to plus minus 1. So how many ordered pairs am I getting in this set? Let me see. So here I'll get 2. Let's see. 2 comma, and remember I'm writing always A first, plus 3. 2 minus 3. Okay. Then I have minus 2 plus 3 and minus 2 minus 3 and 4 and 1 and 4 and minus 1, then minus 4 and 1 and minus 4 and minus 1. So this is the set 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7 and 8. So 8 elements this set has. Note that these are all elements, and after each one I have put a comma. And note another thing, that I have always written AB. I have never written BA. Okay, so these are the ordered pairs, and this is what is ordered pair. Okay, now after ordered pair we'll go for Cartesian product. Okay, so after ordered pair comes Cartesian product. So next is Cartesian products. What are Cartesian product? Now Cartesian product is again another set. It is a set of ordered pairs. Okay, it is a set of ordered pairs where the first element of the ordered pair, that is A, will be taken from one set, and the second element, that is B, will be taken from a different set. Okay, and then we write, supposing we write A cross B. Okay, so if we write A cross B, then we will write different ordered pairs in it. Okay, we'll have many ordered pairs in it, and each one, the first element will be taken from A and the second element will be taken from B. So we know ordered pairs now. Now Cartesian product between two sets A and B, first element will come from A and the set A, and the second element will come from set B. Let us see this example. X belongs to natural numbers and X is less than equal to 4. Y belongs to again natural numbers. Now each element in B is being called a Y. Okay, and Y will lie between 3 to 5. We have to find A cross A. First what we will do is we will find A. We'll find A. Now what are the elements of A? 1, 2, 3 and 4. What are the elements of B? B will not include only 4 and 5. Am I right? B is only 4 and 5. So now we will find A cross A. Now what is A cross A meaning? We'll make ordered pairs only from elements of this. Okay. So that is, one is 1, 2, right? Comma. See, one ordered pair done. 1, 3, 1, 4. Yeah. And then 2, 4. And then 2, 3, 4. Okay, then we'll take 4, 1. We have 1, 4, but now 4, 1 is a different ordered pair. Okay, 4, 1, 3, 1, 2, 1. Okay, now we'll get more. 4, 2, 4, 3. Okay, 4, 3, 2 and 3, 1, 1, 3 is there, but 3, 1, yeah, done. So how many are we getting? Have we missed any? Now we need 1 comma 1 also, 2 comma 2 also, 3 comma 3 and 4 comma 4. So let me see how many we got. So we got a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. We need one more. Okay, 1 comma 2, 1 comma 3, 1 comma 4, 2 comma 2 comma 3 is missing. Okay, so that, how did I know that now it is over? Because this is over now, because it is, I have got 16. If there are 4 elements, a cross a both have 4, it means like this: 1 2 3 4, 1 2 3 and 4, each one gets 4, each one gets 4. That is why, okay, so if there are 4 here and the other, this is also set A, this is also set A, so if the cardinal number of set A is 4 and the cardinal, therefore the cardinal number of A cross A will be 4 into 4. That is why I was looking for 16 of them. Now let me now get A cross B. Okay, how to get A cross B? Now, you'll see that we'll get some elements. This time we are going to get only 8 elements. 4 into 2, 8 elements. 1 comma 4, 2 comma 4, 3 comma 4. Okay, 1 comma 4, 2 comma 4, 3 comma 4 and 4 comma 4. Yes, and then we are going to get 2 comma 3 comma 4 comma 4 and then 1 comma 5, 2 comma 5, 3 comma 5, 4 comma 5. Okay, so how many we got? We got 8. Okay, we got 8 of them. So this is, cardinal number of this set is 8. Cardinal number of this set is a 16th. Okay, so this is what the meaning of Cartesian product is. Means we call this a Cartesian product of A cross A. This is also a Cartesian product. So we call this a Cartesian product. Why is it a Cartesian product? Because it is a set of ordered pairs between two sets. Okay, one is set A and one is set B. It can also be itself. This is A cross B, but this is from two different sets. Okay, so that makes it a Cartesian product when each of the elements of this is an ordered pair. Okay, after this we have relations. Now, relation is actually a subset of a Cartesian product. Means a small part of this one, I can say. So I have to tell the condition of the relation. What is the relation? So if I give the relation, is A is, okay, or X is greater than Y in A cross A. This is my relation. If I give this relation, then I will get another set now. Okay, which is, let's say, so relation P, let's say relation P, and that becomes what now? That is a subset of a Cartesian product. So relation is a subset of a Cartesian product where I have, let me take X greater than Y. Which are those? 4 comma 1, 4 comma 2, 4 comma 3. Next is, after 4 comma 3, I'll have to look for other numbers. 3 comma 1, 3 comma 1, 3 comma 2. Okay, I can't take 3 comma 3. Then 2 comma 1. Is there anything else which is, the first one is bigger than the second one? I don't have anything else. So the relation is this set. So this set becomes the relation. So in a relation, you will always have to give a condition. These all, the members of the relation, I can call it the relation set, has to follow this condition. Same thing, I can find a relation in here also. Okay, so if I find X is greater than Y in this, or if I say X is equal to Y in, let's say this, I don't have any X is equal, I have, Okay, so the relation, let's say R is 4 comma 4. So it has only one element. Okay, so this is called a relation. The next thing after relations comes functions. What is a function? Now function is from a relation. Okay, so I will draw it first. So function is, you can say, it is like this. The relation was like this, 4 and 3, right, and 2, and this side I have 1, 2, 3. Now it goes like this, 4 comma 1, 4 comma 2, and 3 comma 1 and 3 comma 2, and 2 comma 1 and okay, 2 comma 1, that's it. I can't do 2 comma 3. But then this mapping is not a function. Okay, this particular relation does not qualify as a function, not a function. Why? I'll tell you. When does a relation become a function? If I talk about functions, remember this. I have one set here, another set here, A, B. Now, if there is any function which is, if there is any relation which is linked like this, even at one place, okay, these are all elements here in this set, okay, so even at one set, if it gets this, means two of these have is linked to one, this side, to the first one, to the first component, to the first set, it is not a function. Okay, so if it is if it has to become a function, it can be just one to one linking, like it can be like this, okay, only one to one, or it can also be like this, no problem. Okay, but then it can be like this, but then it cannot be this sign, remember, okay, the less than sign, it cannot be the less than sign, means 2 or on the right linked 1 to 1 in the left, that is not a function. Anyway, so this is not a function, here this is a function. Okay, this one is a function because it is either 1 this can have many, linked to many here, but one cannot be linked to many. Okay, now here I want to tell, this side is the domain. Okay, even in a relation, this side we call the domain, this side we call, now let me put more elements here. Okay, if I put more elements, let me put 1, 2, 3, 4, A, B, C, D, E and F. So this full set, okay, set A and set B, A is the domain, B is the co-domain, okay, B, full set B, A, B, C, D, E, F is the co-domain. But then what is range? Range is this set, see, range is only A and B, because the only those which are linked to some element to the left which are forming ordered pairs, that comes under range, but codomain is the full thing. So range is a subset of a codomain. Okay, range is a subset of the codomain. You want me to write this domain here in this particular one? Domain is 1, 2, 3, 4. Okay, if I write codomain is A, B, C, D, E and F. Okay, codomain is A, B, C, D, E and F, that is the full thing. But range, you see, only the linked ones become the range. Now, these will also be called the image. Okay, and the domain will be called the pre-image. Pre-image. So, these images have these pre-images. Okay, if you want me to form ordered pairs of this, I can form ordered pairs of this. That is going to be For ordered pairs of this, I can link like this: 1 comma A, 2 comma B, okay, 3 comma B, and 4 comma B, okay, not anymore. This is the function. This is the one which is, these are the ordered pairs that can be made from this function, okay. So now hopefully you have understood what is an ordered pair, what is a Cartesian product, what are relations, and what are functions. Now functions, there are many types. In my next video I am going to do the different types of functions, okay, and in the more videos that are going to come up, I am going to take up exercises in ordered pairs, Cartesian products, relations, and functions separately, finding the domain, etc. Okay, so here you can just check in the playlist, you'll get them. So here this is, so I hope you have understood. Let me quickly recap the full thing. So first comes a ordered pair, which is like this, okay, A comma B, okay, there can be many like this. Now the second one comes, is after ordered pair comes Cartesian product, Cartesian product, that is, which comes like A cross B, and that comes as A comma B, then it will be many more like this, okay, depending on if this one's cardinal number is 3, this one's is 2, then the cardinal number of A cross B is a 6. So NA into NB is equal to NA cross B. This is something to remember. Okay, let's come to the next one. After Cartesian product, a small part of a Cartesian product can be called a relation if it is following a particular rule. Okay, the rule will be provided to you. So if it is following a particular rule, okay, A is equal to B, A is greater than B, B is greater than A, something like that. So then we get a relation. So a relation is actually a subset of a Cartesian product. So few elements will come under that condition, and that we will get another set which will be called a relation. Now the relation further, not a subset, I am not saying it's a subset, a relation further gets classified as a function or not a function. It can be a function if it is always either 1 1, or it is like this. It is a function if it is like this, okay, many 1. So either 1 1 or many 1 can form a function. Yes, so these are functions. So these two types are functions, okay. But then what is not a function? If I have this sign, if I have the less than sign, then it does not qualify as a function. Okay, so starting from ordered pair, then Cartesian product, then relation, and then function. Next is about 5 to 6 types of functions, okay, then algebra between functions, and then we are also going to do, after 5 to 6 types of functions, algebra between functions, then we are also going to do what is a many one function, one many function, things like that. So these are the few things that is going to be taken up in the next video, so don't miss it, okay. So you can go through it several times to get your concept clear, okay. So that is it for today in this video. If you have liked the video, do not forget to like, share, and subscribe. Also, you can leave a comment behind. It's really motivating for me to read your comments. Okay then, bye all of you. Thanks.